Now, in depth first search, we start from the source vertex, obviously, and we don't proceed by exploring all the adjacent vertices or all the vertices which are adjacent to the vertex. We perform the exploration depth-wise. So obviously, depth first search starts with the vertex, that is the source vertex we call. We select one adjacent vertex, not all adjacent. As in breadth first search, we explore all adjacent vertices. Here in depth first search, we only select one adjacent vertex. That means one edge. And then we mark that vertex as visited. We continue this procedure until there are no more edges left to be explored. And finally, it terminates. So the difference between breadth first and depth first search is, in breadth first search, we try to explore all the vertices of a vertex. But in depth first search, we start exploring one vertex, one adjacent vertex. Then its adjacent vertex, until all the edges are explored. Now, the way this happens, for example, you have seen the just now we have seen the algorithm for breadth first search. It uses iteration to find what all vertices are adjacent, and then make use of a cube. Whereas depth first search, as the procedure involves, so it's picking up one adjacent vertex and its adjacent vertex. So it's like a recursive procedure. So breadth first search is an iterative procedure and depth first search is a recursive procedure. Now, let us look at how depth first search works. We start with vertex 1. Even here we will have an array of number of vertices as a visited array, and we will start depth DFS, the arrow and DFS you can see here. It's pointing to the first vertex. Now we visit this vertex. We mark this vertex as visited. Then we can pick any of its adjacent. We have to pick only one adjacent vertex. We can pick any one, 2 or 3. But usually what happens is, since we have to do this programmatically, so we will follow how the nodes are or the vertices are numbered. So we will pick one vertex, that is vertex 2. Now this vertex is visited, and visited in depth first search manner and marked as visited. Then its adjacent vertex is selected. Now we are not selecting vertex 3 now. It's adjacent. It's in the sense DFS is at this point. So we performed DFS now from node 2. So its adjacent is vertex 4. Now this vertex 4 is visited and obviously marked as visited the visited array. Then its adjacent vertex, which is now vertex 8. This vertex 8 is visited, marked as visited, and then which adjacent vertex we have to pick. 8 has an adjacent vertex 4. Now from 8 we have to pick an adjacent vertex. It has a vertex 4, but vertex 4 is already visited because it's marked in the visited array. So we cannot pick vertex 4. Then we will pick vertex 5. Vertex 5 is not visited yet. So we mark it as visited. We visit that vertex and mark it as visited. From vertex 5, the adjacent edge is vertex 2. Is vertex 2 visited? Vertex 2 is already visited because we have marked it in the visited array. So it will not visit vertex 2. Then, since it's a recursive procedure, it comes back to vertex 8. From vertex 8, what is the next adjacent vertex? It's vertex 6. It's not visited, so we visit vertex 6 and mark vertex 6 as visited. Then its adjacent vertex is vertex 3. It's not visited yet, so we visit vertex 3 and mark it as visited. And then from vertex 3 we can go to vertex 1. But is vertex 1 visited? Yes, vertex 1 is already visited. It's marked as visited, so we don't visit vertex 1. Then the next is vertex 6. It's also marked as visited, so we don't visit vertex 6. Only thing left out is vertex 7. So we visit vertex 7, mark vertex 7 as visited. And then from vertex 7, we move to vertex 8 because that the edge are available, but vertex is already visited, so we don't proceed further. We move to vertex 3, back to vertex 3. Then because it's a recursive procedure, the way we have come, we go, move the same, we take the same path backwards. Then vertex 8, because we came from vertex 4, so we move to vertex 4, vertex 2, and finally we will reach vertex 1. And you can see all the edges are explored. Once all the edges are explored, that is traversed, then the depth first search terminates and we have the result. So you can see for the same graph, breadth first search and depth first search may give different results, different output, or different way that we can visit or traverse vertices. Now let us look at the algorithm for this one. The algorithm for depth first is very simple. It's very small because we use recursion here. So we start with, I've used this as function, but don't say function, you use algorithm here, depth first search. We start with the first vertex. We mark that visited. This visited is a global array. Everything is exactly 0. If it is 1, that means it's marked. So visited of V is 1. Then for each vertex, which is adjacent to V, because we are at a time we are picking one vertex, but for every vertex that is adjacent we have to see. So for each vertex which is adjacent to the vertex we have started from, if it is not visited, then we recursively call depth first search, passing that only one adjacent vertex, that is W. So next time, if there are 2, 3 adjacent vertices, then next time when depth first search comes, this vertex, next vertex will be passed in the recursively. So this is just 3 or 4 lines of code is there for, the algorithm for depth first search. So always remember that breadth first search works iteratively and depth first search works recursively.